Number 60. Find the area bounded by the two curves shown on the right. So, first thing we have to do is find the equation of both of these curves. So, the first one I'm going to look at is this square root curve on the bottom, this curve right here. And this one is pretty distinctive. Just working with graphs for a little bit, most people can recognize this. This is just the curve of y equals square root of x. And you can actually verify this if you wanted to. Just look at your points. So you have 0, 0. So yes, 0 is the square root of 0. And then right here you have 1, 1. 1 is the square root of 1. Here you have 4, 2. 2 is the square root of 4. And then 3, 9. And it's just going to keep going. So our first curve is y equals the square root of x. The second one is a little bit trickier, but just for the sake of the problem, I'm going to show you how to use a quadratic regression to find the equation of this parabola. So let's see, we have, okay, what are our points? We have 4, 6, we have 6, 0, and we have 8, 4. Or wait, nope. 4, 4, not 4, 6. 4, 4, 6, 0, and 8, 4. Yes. So I'm going to go to my calculator and do menu, statistics, stat calculations, and the number 6 is quadratic regression. And then if I just put in my x list and y list, so 4, 6, 8, and then my y list, I believe it was 404, maybe. Yes, 404. And then I see that's at F2, but actually for this problem it doesn't really matter that much. So let's see, we have x squared minus 12x plus 36. So for this equation, y equals x squared minus 12x plus 36. So if you want to find the area bounded by these two curves, the next thing you have to know is where these intersect. And these will help us find the bounds of our integration. So to find where these intersect, it's pretty straightforward. All you have to do is just find when they're equal to each other. And we can do a solver to figure that out. So to do that, you just go to menu, and then 3 for algebra, and then 1 for solve. And then we have square root of x equals x squared minus 12x plus 36. Solve for x. And so our bounds are at 4.54 and 7.66. 4.54 and 7.66. Now once we have this, we can just set up our integral for the bounded area. So if you define the define the bounded area using an integral, what you do is you just take the integral between your two boundaries. In this case, it'll be 4.54 and 7.66. And then just do that and then inside your integral, you just do the upper function minus the lower function. So pretty much what happens is whenever you do the upper function, you find all of this area. So if I'm going from here to here, the upper function on this interval would be y equals square root of x. So you're finding all of this area. So if I just did square root of x, that would tell you all that area. And then the reason you subtract out x squared minus 12x plus 36, well, that's because you don't actually want all that area. You want to subtract out the area that is underneath right here. And when you do that, you can see we're just left with this area right here. So we just need to set up our integral in our calculator. So let's see. To do the integral, you can either do menu 4 and then integral is 3. Or the other thing you can do, and I think it's a little bit faster, you can just do shift plus, and that'll also give you an integral. So let's see, 4.54028 to 7.66384 of the square root of x minus x squared minus 12x plus 36 dx. And hopefully this gives us an answer. Let's see, 5, I think it's the nearest tenth, so 5.1. And it looks like, yes, that is answer choice E. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I'll see you next time.